8:47 p.m. on the night of August 28, 1945, Lieutenant Commander Stephen Johnson stood in the conning tower of the American submarine Sigundu, staring at his radar display with increasing disbelief. The Pacific Ocean was calm. A gentle swell rolled beneath the hull. The only noises were the low hum of electronic equipment and the distant pulse of diesel engines driving the Sigundu through the darkness at 12 knots. 13 days had passed since Japan had announced its surrender. The war was finished. American sailors were already imagining their return home. Then the radar operator called out a contact, bearing 045 degrees, range 12,000 yards. Johnson leaned closer to the screen and felt his stomach tighten. The contact made no sense. The radar return was far too large for a submarine, much too large. The signal suggested a vessel the size of a destroyer. Yet a destroyer would not appear alone. It would have escorts, multiple contacts, a recognizable formation. This contact was solitary. Johnson had spent the war tracking Japanese submarines. He understood their radar profiles, their capabilities, and their limitations. The largest submarines in the Imperial Japanese Navy displaced roughly 2,500 tons. This contact implied something twice that size, something that should not have existed. Johnson ordered the crew to battle stations. The Sigundu was a Belau-class submarine, 311 feet long and displacing 2,400 tons when submerged. She was among the most advanced submarines in the American fleet. Yet as the Sigundu closed the distance, Johnson realized he was approaching a vessel that dwarfed his own. The silhouette emerging from the darkness was not a destroyer. It was a submarine larger than any submarine the United States Navy had ever constructed. What Johnson encountered that night would remain classified for decades. The vessel carried technology American engineers had never conceived. It represented a weapon system so advanced that the United States would later sink it to the floor of the Pacific rather than risk another nation uncovering its secrets. This is the story of the largest submarine of the Second World War, a vessel designed to strike the American mainland from the sea, a weapon that came within hours of altering the course of history. The concept originated in the mind of a single man just 3 weeks after Pearl Harbor. Admiral Isoroku Yamamoto was 57 years old in January 1942. He had lost 2 fingers at the Battle of Tsushima during the Russo-Japanese War in 1905. Shrapnel scars marked his abdomen, and he walked with the slight stiffness of a man who had experienced combat firsthand. Yamamoto was the architect of the December 7th attack on Pearl Harbor. He had planned it, supervised its execution, and watched reports arrive as American battleships burned and sank at their moorings. The operation had been a tactical triumph. Yet Yamamoto understood something few of his peers grasped. He had studied at Harvard University from 1919 to 1921. He had served twice as a naval attaché in Washington, learning English, playing poker, and immersing himself in American culture. He traveled extensively across the United States, toured factories, and observed production lines capable of manufacturing automobiles and appliances in quantities Japan could never equal. He understood American industrial power better than almost any officer in the Imperial Japanese Navy. And he knew Japan had awakened a sleeping giant. In the weeks following Pearl Harbor, as Japanese forces swept across Southeast Asia and the Pacific, Yamamoto calculated the mathematics of attrition. America had lost battleships, but American shipyards were already laying keels for replacements. By 1943, the United States would be producing aircraft carriers faster than Japan could destroy them. By 1944, the balance of power would tilt permanently. By 1945, Japan would face annihilation. Yamamoto needed a weapon capable of striking America before the industrial tide became unstoppable. Not aircraft carriers, which Japan could not replace as quickly as America could build them. Not battleships, which consumed immense resources to construct and maintain. He needed something unexpected, something America would neither anticipate nor easily counter. Submarines, but not conventional ones. Yamamoto envisioned underwater aircraft carriers, vessels large enough to cross any ocean, submarines that could surface off the coasts of New York or San Francisco, launch bombers, and vanish beneath the waves before defenders could react. On January 13, 1942, Yamamoto submitted his proposal to Fleet Headquarters. He requested 18 enormous submarines, each capable of carrying multiple attack aircraft. Each submarine would possess the range to circle the globe 1.5 times without refueling. Each would carry sufficient fuel, provisions, and ammunition to remain at sea for 4 months. The proposal exceeded anything previously attempted. The largest American fleet submarines displaced 2,400 tons. Yamamoto sought vessels displacing more than 6,000 tons. The technology required did not yet exist. The engineering challenges appeared overwhelming, but Japan was desperate, and desperate nations attempt the impossible. Captain Kamato Kuroshima led the feasibility study. Known throughout the fleet as a brilliant yet eccentric officer, His analytical methods and tactical insight had earned Yamamoto's confidence. His evaluation was meticulous and uncompromising. By March 17, 1942, preliminary designs were completed. The submarines would measure 400 feet in length, nearly 100 feet longer than any American submarine. They would be 39 feet wide, almost double the beam of conventional designs. Their draft would be 23 feet. They would displace 5,900 tons on the surface and 6,500 tons submerged, more than twice that of American fleet submarines. The design demanded revolutionary engineering. A traditional submarine hull could not support the weight of an aircraft hangar on its deck. Engineers therefore devised a double hull structure featuring two parallel pressure cylinders joined in a figure-8 cross-section, providing the strength required to support the massive superstructure. This innovation would influence submarine design for decades. The hangar formed the core of the concept, 115 feet long and 11 feet in diameter, built of steel thick enough to withstand pressure at 330 feet below the surface. It was sealed by a 2-inch thick rubber gasket that could be hydraulically opened from within when the submarine surfaced. Inside, 3 attack aircraft would be stored with wings folded and tails collapsed, awaiting launch against an unsuspecting target. 4 diesel engines producing a combined 9,000 horsepower would drive the submarine at nearly 19 knots on the surface. 2 electric motors generating 4,200 horsepower would propel the vessel at 6.5 knots submerged. Fuel tanks would carry enough diesel to cover 37,500 nautical miles, 1.5 times around the Earth, without refueling. The aircraft themselves required an entirely new design. The Aichi Aircraft Company received the contract in May 1942. The requirements appeared impossible. The plane had to fit inside an 11-foot diameter cylinder. It had to carry heavy ordnance. It had to be fast enough to survive encounters with enemy fighters. It also needed the ability to land on water for recovery by the submarine. Aichi engineers spent months developing solutions. Their final design, designated the M6A1 Siren, meaning mountain haze, was a triumph of compact engineering. It was a 2-seat, low-wing monoplane powered by a 1,400 horsepower Otsuta engine, a license-built version of the German Daimler-Benz DB601. The engine drove a 3-bladed propeller and could propel the aircraft to 295 miles per hour. Comparable to many land-based fighters, the Siren could carry an 1,800-pound bomb beneath the fuselage or a Type 91 aerial torpedo. A single 13mm machine gun on a flexible rear mount provided defensive armament. With a range of 740 miles, the aircraft could strike deep inland and return to its submarine. The true innovation lay in the folding system. The Siren's wings rotated 90 degrees and folded hydraulically along the fuselage, reducing the wingspan from 40 feet to just under 12. The horizontal stabilizers folded downward, and the upper section of the vertical stabilizer collapsed as well. Detachable twin floats were stored in separate compartments alongside the hangar. Assembly points were coated with fluorescent paint to allow crews to work in darkness. A trained 4-man team could roll a Siren from the hangar on a collapsible trolley, attach the floats, unfold the wings and tail, and prepare the aircraft for launch in approximately 7 minutes. The engine posed a particular challenge. Aircraft engines typically require warm-up time, but a surfaced submarine was extremely vulnerable. Every minute on the surface increased the chance of detection. To solve this, engineers created a system to preheat engine oil to 140 degrees Fahrenheit in a separate chamber inside the submarine. Just before launch, the heated oil and water were circulated through the engine while the aircraft remained inside the hangar. The Siren would be catapulted from a cold start with its engine already at operating temperature. It was a dangerous procedure, but it allowed all 3 aircraft to be launched within 45 minutes of surfacing. Only 28 Sians were ever built, including 8 prototypes. A land-based trainer version called Nansen, meaning Southern Mountain, was developed to help pilots learn the aircraft without risking the precious float planes. But shortages of materials and labor meant that even these small numbers were difficult to achieve. Construction began on January 18, 1943. At the Curry Naval Arsenal, the I-400 was laid down as submarine number 5231. Workers labored around the clock in the massive shipyard, their welding torches casting flickering shadows on the growing hull. The vessel was so large that special cranes had to be constructed to lift sections into place. Allied bombing raids grew more frequent as the months passed. American B-29 bombers struck industrial targets across Japan. The shipyard workers learned to scatter when the air raid sirens wailed, seeking shelter in the concrete bunkers that dotted the facility. Then they returned to work, often finding their equipment damaged, their materials scattered, their progress set back by hours or days. Steel shortages forced compromises. Japan's merchant fleet was being decimated by American submarines. the very weapon Japan had once dominated. Shipments of raw materials from occupied territories slowed to a trickle. The quality of steel declined as impurities increased. Workers had to reject more and more material as unsuitable. Labor shortages meant that schoolgirls as young as 12 worked in the shipyards and aircraft factories. These children, called volunteer workers, handled rivets, sorted parts, and performed tasks that freed adult workers for more complex operations. They worked long hours in conditions that would have been considered unsafe, even by wartime standards. An earthquake near Nagoya on December 7, 1944, damaged the HIF factory and delayed production of the Syrian aircraft. American air raids on March 12, 1945, struck the same facility again. Production schedules that were already impossible to meet slipped further behind. Originally, 18 submarines were planned. Yamamoto's vision called for a fleet of underwater aircraft carriers that could strike any target on Earth, but reality intervened at every step. The number was reduced to 9 after Yamamoto's death, then to 5 as steel and labor shortages mounted. Finally, only 3 would be completed before the war ended. A fourth, the I-404, was 90% complete when construction was halted in March 1945. A fifth was converted to a fuel tanker because Japan needed oil more than it needed another aircraft carrier. 13 planned vessels were cancelled before construction even began. Admiral Yamamoto never saw his vision realized. On April 14, 1943, American radio intercept stations copied an encrypted Japanese naval message. Codebreakers at the Fleet Radio Unit Pacific at Pearl Harbor, working with their counterparts in Washington, spent hours deciphering the transmission. What they found was extraordinary. The message contained a detailed itinerary for Admiral Yamamoto, commander of the Combined Fleet, the most important naval officer in Japan. Yamamoto was planning an inspection tour of Japanese bases near Bougainville in the Solomon Islands. His schedule was precise, timed to the minute. He would depart Rabaul at 600 hours on April 18 aboard a Mitsubishi G4M bomber escorted by 6 Nero fighters. He would arrive at Ballet Airfield at 7:45. Admiral Chester Nimitz, commander of the Pacific Fleet, faced a decision. The information was invaluable, but using it risked revealing that America had broken Japanese codes. If Yamamoto's aircraft was shot down, the Japanese might realize their communications were compromised. They might change their encryption systems. The intelligence advantage that had helped win the Battle of Midway might be lost. Nimitz consulted with Admiral William Halsey, commander of South Pacific Forces. Both men understood what Yamamoto meant to Japan. He was the architect of Pearl Harbor. He was the most experienced and innovative naval strategist in the Japanese fleet. His death would be a blow to Japanese morale that could not be measured in ships or aircraft. Nimitz authorized the mission on April 18, 1943, exactly 1 year after the Doolittle raid on Tokyo 18 P-30. Lightning fighters from the 339 Fighter Squadron took off from Henderson Field on Guadalcanal. Major John Mitchell led the formation. They flew at wavetop level for over 2 hours, navigating by dead reckoning, maintaining radio silence, circling around the Solomon Islands to avoid detection. They reached the interception point on time. 2 bombers appeared, escorted by 6 Nero. The American fighters attacked. Captain Thomas Lampiette and Lieutenant Rex Barber dove on the bombers while the cover flight engaged the escorts. Yamamoto's aircraft went down in the jungle. His Chief of Staff, Vice Admiral M.T.O. Mogaki, survived the crash of the second bomber into the sea. Japanese search parties found Yamamoto's body still strapped to his seat, thrown from the aircraft, but still clutching his samurai sword. An autopsy found 2 bullet wounds. He was 59 years old. The guiding hand behind the I-400 program was gone, but the submarines continued to take shape in the shipyards of Cuba and Cebu, built by workers who did not know that the admiral who had conceived their mission would never see them completed. The I-400 was commissioned on December 30, 1944. Commander Toshio Kasaka assumed command. He was an experienced submarine officer who had previously commanded the I-26, the I-174 and the I-180. He understood the capabilities and limitations of undersea warfare, but nothing in his experience had prepared him for a vessel like the I-400. The submarine was a floating city. 144 officers and enlisted men lived aboard. During operation, the vessel carried 20 Type 95 torpedoes for its 8 forward torpedo tubes. A 5.5 in deck gun sat aft of the hangar. 3 triple-mounted 25mm anti-aircraft guns protected against air attack. Radar systems, both air search and surface search, provided early warning. Demagnetization cables ran along the hull to protect against magnetic mines, and a Newick coating absorbed sonar pulses to reduce the submarine's acoustic signature. But the I-400 had weaknesses that Kusaka understood immediately. The massive hangar and offset conning tower created a significant radar signature on the surface. The submarine took 56 seconds to dive, nearly double the time required by American fleet submarines. When submerged at slow speed, the offset superstructure forced the helmsman to steer 7 degrees to starboard just to maintain a straight course. The vessel was difficult to maneuver in combat. The I-400 was not designed for submarine warfare. It was designed to deliver aircraft, and the target for those aircraft was the Panama Canal. The Panama Canal was the jugular vein of American logistics. Ships carrying men and supplies from the Atlantic to the Pacific entered the canal at Colón on the Caribbean coast. They passed through the Gatun locks, a triple flight that raised vessels 86 feet to the level of Gatun Lake. They crossed the lake, transited the Culebra cut through the Continental Divide, descended through the Pedro Miguel and Merlos locks, and emerged at Panama City on the Pacific side. The transit took approximately 8 hours. Without it, ships would have to sail around Cape Horn at the tip of South America, adding over 8,000 miles and weeks of transit time to every voyage. The canal was heavily defended. Fort Sherman on the Atlantic side mounted coastal artillery batteries with a range of 70 miles, preventing enemy ships from approaching close enough to shell the locks. Fort Hamada on the Pacific side provided similar protection. Barrage balloons floated over the lock structures. Anti-submarine nets guarded both entrances. The 88th Coast Artillery Regiment manned anti-aircraft position. Fighter aircraft patrolled from bases on both sides of the isthmus, but the defenses were designed against conventional attack. A surface fleet approaching from the sea, bombers flying from distant bases with time to be detected and intercepted. No one had considered that an attack might come from submarines carrying aircraft. In August 1943, Captain Chika Yamamoto, no relation to the Admiral and Commander Yasu Fujimori, conceived the plan. A Japanese engineer who had worked on the canal during its construction provided invaluable intelligence. He handed over hundreds of documents, including blueprints of the lock structures, specifications for the lock gates, descriptions of the construction methods used. Japanese shipping engineers studied the materials. 4 months. Their analysis identified vulnerabilities. The lock gates at mirror floors on the Pacific side were accessible, but their destruction would cause limited damage. The Gatun locks on the Atlantic side offered a more tempting target. Behind those locks lay Gatun Lake, the artificial body of water that ships crossed during their transit. The lake was held in place by the Gatun Dam and the locks themselves. If the lock gates were breached, the water of Gatun Lake would drain into the Caribbean. The canal would be completely inoperable until the gates were repaired and the lake refilled. Intelligence analysts estimated the canal would be unusable for at least 6 months. The attack plan called for 4 submarines. The I-400 and I-401 would each carry 3 Siren aircraft. 2 smaller vessels, the I-13 and I-14, were modified to carry 2 Sirens each, 10 aircraft in total. They would sail eastward across the Pacific to a point 100 miles off the coast of Ecuador. At 3 in the morning on a moonlit night, the submarines would surface and launch their aircraft. The Sirens would be painted with American markings to confuse defenders. They would fly northeast over Colombia, turn west over the Caribbean, and approach the canal from the Atlantic side at dawn. The pilots would dive on the gun locks and release their bomb. After the attack, they would ditch their aircraft near the submarines and be recovered by the waiting vessels. Training began in June 1945 at Nana Bay on the western coast of Honshu. The location was chosen for its isolation from American air attacks and its sheltered waters. All for submarines of Submarine Division 1, the R-400, I-401, I-13, and I-14 gathered there by June 5. 6 Siren aircraft of the 631 Naval Air Group flew in from Kure. The Missouri Naval Arsenal constructed a full-scale wooden mock-up of the Gatun locks, placed it on a raft, and towed it into the bay. The mock-up reproduced the dimensions of the actual lock gates, the angles of approach, the distances that pilots would need to judge during their attack runs. Pilots practiced rapid assembly of their aircraft, night catapult launches, and bombing runs against the mock-up. The training revealed problems that could not be easily solved. Torpedo bombing required precise timing, steady hands, and extensive practice. Only one pilot, Lieutenant Takashi, truly mastered the technique. The others could deliver bombs accurately, but struggled with the more complex torpedo attacks. Eventually, the plan was modified to rely primarily on bomb attacks rather than torpedoes. Catapult launches were dangerous in any conditions. In rough seas, they became potentially fatal. The submarine's pitching and rolling made timing critical. Pilots had to be launched at the precise moment when the deck was level. A mistimed launch could send an aircraft into the water before it gained flying speed. The navigator had to coordinate with a catapult crew watching the submarine's motion, calling out the moment to fire. Lieutenant Atsushi Asamura, one of the Surin pilots, later recalled the difficulty. The compressed air catapult was smoother than gunpowder systems used on other vessels, but launching against the wind was essential for the aircraft to gain enough lift. If the wind direction changed during a catapult launch, the results could be catastrophic. Night operations presented additional challenges. The submarines would need to surface, launch their aircraft, and dive again before dawn revealed their position to enemy patrols. Every step had to be performed in darkness or under minimal lighting. The fluorescent paint on the Submarines assembly points helped, but crews still fumbled with unfamiliar equipment in the confusion of night operation. One Submarine failed to return from a training flight on June 19. The aircraft simply vanished. The bodies of its two crew members, their names now lost to history, washed ashore on Satashima Island days later. The cause of the crash was never determined. By June 20, 1945, training was complete. The crews had achieved the best proficiency that time and resources allowed. The operation was ready to proceed. The submarines would sail within days to strike the Panama Canal and change the course of the war. Then Okinawa fell. The fall of Okinawa changed everything. American forces were now within striking distance of the Japanese home islands. The Panama Canal operation, which might have delayed American logistics for months, would have no impact on the coming invasion. The Imperial Japanese Navy General Staff led the attack. Instead, the submarines received new orders. They would attack the American fleet anchorage at Ulithi Atoll in the Caroline Islands. Uli was the staging point for American air raids against Japan. Dozens of aircraft carriers, battleships, and supply vessels anchored there between operation. A successful strike could destroy ships and aircraft preparing for the invasion of Japan. The plan was desperate. The pilots would not ditch and be recovered. They would fly one-way missions, kamikaze attacks. On July 18, 1945, a farewell ceremony was held at the Sherto Inn in Missouri. Vice Admiral Tadashi Daigo, commander and chief of the 6th Fleet, raised a sake toast to the pilots of the 631 Naval Air Group. Captain Tatsunosuke Arasumi, commander of Submarine Division 1, presented ritual short swords to the air crews. Captain Arasumi was a controversial figure. He had commanded the submarine I-8 earlier in the war. During that command, he had ordered the execution of survivors from ships his submarine had sunk. On March 26, 1944, his crew massacred 98 survivors of the Dutch merchant ship Chaislac in the Indian Ocean. Arasumi personally executed several of the ship's officers. The British called him the Butcher. Now, Arasumi commanded the largest submarines ever built, carrying pilots who would sacrifice their lives for a dying empire. The I-400 departed Amanado at 1,400 hours on July 23. The I-401 followed 2 hours later with Captain Arasumi aboard as flotilla commander. The submarines took separate routes across the Pacific to avoid detection, planning to render south of Panapai Island on August 16 before launching the attack on Ulithi. The voyage was a test of endurance and nerves.
The submarines traveled mostly submerged during daylight hours to avoid American patrol aircraft.
They surfaced at night to recharge their batteries and refresh the air inside the hull.
The crews lived in conditions that would have been miserable even for experienced submariners.
The I-400 carried 144 men in a space designed for efficiency rather than comfort.
Bunks were stacked 3 high.
The air grew stale quickly when
submerged. Temperatures in tropical waters rose to unbearable levels. Unlike American submarines, which had air conditioning to control interior temperatures, Japanese boats offered no such luxury.
Men sweated through their watches, their uniforms soaked, their concentration frayed by the oppressive
heat. The toilets were primitive by any standard. Japanese submarines of this era did not have flush toilets. Waste had to be disposed of carefully to avoid detection by enemy sooner.
The smell inside the hull was a constant presence that veterans described in terms that cannot be repeated in polite company. Food was another challenge.
The
submarines carried provisions for 4 months. Rice, dried fish, preserved vegetables, and canned goods formed the
basis of every meal. Fresh food was consumed first and then forgotten.
The monotony of the diet matched the
monotony of the voyage.
Endless days of waiting punctuated by moments of terror when enemy contacts appeared on Suna. The voyage was plagued with difficulties beyond the ordinary hardships of submarine operation.
On July 23, just
hours after departure, the I-41 passed through the Chuguru Strait between Honshu and Hokkaido.
2
Japanese Army coastal artillery batteries on the Hokkaido shore mistook her for an enemy submarine and opened
fire. Type 96 150mm howitzer shells crashed into the water around the submarine.
One landed 300 meters off the port quarter, close enough to spray the deck with seawater.
Arasumi ordered an emergency dive.
The submarine plunged beneath the surface while confused radio messages flew between naval and army commands.
The friendly fire incident could have ended the mission before it began. When the I-401 surfaced after exiting the strait, Izumi transmitted an angry protest to naval headquarters. A typhoon struck on July 28 and 29.
The massive submarines rode the storm better than smaller vessels would have.
Their double-hull construction provided stability,
their size giving the inertia against the rolling seas, but the delay threw off their carefully calculated schedule. Time that should have been spent traveling toward the target was lost riding out the storm.
On August
5, the I-400 suffered an electrical fire in a portside control panel. Smoke filled the compartment.
Commander Kusaka ordered an emergency surface, the submarine breaching the wave in a maneuver that would have revealed her
position to any watching aircraft. His lookout spotted an American convoy in the distance. Gray shapes on the horizon. That could have spelled doom for the mission.
Kusaka ordered a crash dive. The submarine descended rapidly,
trailing smoke from her still smoldering electrical systems. For 5 hours, the I-400 sat just below the surface while
engineers worked frantically to repair the damage.
The crew waited in stifling heat, smoke burning their eyes and lungs, listening for the splash of depth charges that never came. The convoy passed without detecting them.
The submarines pressed on toward their rendezvous. Arayumi changed the meeting point multiple times as American air and surface activity increased near the original location. Radio transmissions were kept to a minimum to avoid
detection, but each change of plan required communication.
On August 14,
he transmitted new coordinates to the I-400, ordering the submarine to meet at a point 100 nautical miles south of
Panup.
The message was never received. The I-400, her communications equipment,
damaged in the electrical fire, continued toward the original rendezvous point.
The 2 submarines that were supposed to attack together would not find each other. That same day, the situation in Japan had changed forever.
The first atomic bomb had fallen on Hiroshima on August 6. The second had destroyed Nagasaki on August 9.
Emperor Hirohito announced Japan's surrender on August 15.
The crews of the submarines did not believe the announcement.
4 days,
conflicting orders arrived from Tokyo.
One message confirmed that peace had been declared.
Another ordered all submarines to execute predetermined missions and attack the enemy if discovered. Arayumi initially chose to continue the attack, but on August 18, at 2100 hours, the Sixth Fleet transmitted explicit orders to cancel the operation. The submarines were to return to Cure and surrender. The pilots of the 631 Naval Air Group would not fly their final mission, but they would not allow their aircraft to fall into enemy hands. On August 22, the crews of the I-400 and I-401 assembled their Submarine aircraft on deck. The planes were still painted with American markings from the planned deception operation. One by one, the bombers were rolled onto the catapult and launched unmanned into the sea, wings unfolded, propellers spinning, empty cockpits. The aircraft climbed briefly, stalled, and plunged into the Pacific. The torpedoes were fired without arming. The bombs were dumped overboard. The codes, logs, and charts were destroyed. Everything that could reveal the submarine's capabilities was eliminated. The I-400 hoisted the black flag of surrender. On August 27, American destroyers Blue and Mansfield intercepted her 500 m northeast of Tokyo at noon. The sailors on the destroyer stared in disbelief at the vessel before them. The submarine was nearly as long as the Blue and just as wide. The massive hangar dominated the deck. A catapult stretched along the forward section. A crane protruded from the structure. Nothing in their experience had prepared them for what they were seeing. The Americans had believed they knew everything about Japanese submarine technology. They had captured vessels, studied wreckage, interrogated prisoners, but they had never heard of anything like the I-400. The existence of the submarine aircraft carrier program had remained a closely guarded secret throughout the war. A prize crew from the destroyer escort Weaver led by Commander Ham Cassidy boarded the I-400 on August 28. Cassidy was a veteran submarine officer who had commanded the Sea Raven and the Tigran. He had spent years studying submarine design and capabilities. Even he was astonished by what he found. The massive hangar could have held a small aircraft factory. The catapult system was more sophisticated than anything the Americans had developed. The crane for recovering aircraft demonstrated engineering solutions that American designers had never attempted. The Inuit coating on the hull designed to absorb sonar pulses represented technology that America was only beginning to explore. The snorkel system, allowing the submarine to run its diesel engines while submerged, was more advanced than German designs that American engineers had studied after the fall of the Third Reich. The I-400's crew had destroyed what they could, but the vessel itself remained intact, and it represented a technological prize of incalculable value. 2 days later, Lieutenant Commander Johnson and the Sagundu encountered the I-401 under similar circumstances. Johnson's first conversation with Lieutenant Muno Bando, the Japanese navigation officer who negotiated the surrender, was conducted in what Johnson later described as baby talk plus violent gestures. Bando claimed the submarine carried 200 men. Johnson assumed this was a translation error. It was not. Captain Arisumi did not surrender. As the I-401 sailed toward Tokyo Bay under American control, Ariyumi retreated to his cabin. On August 30 in the Philippine Sea of Azuma, he placed a pistol in his mouth and pulled the trigger. His crew wrapped his body in a Japanese flag and disposed of it through a hatch without the Americans noticing. Ariyumi knew that his war crimes would be prosecuted. He chose death over judgment. The American flag was raised over the I-401 at 500 hours. On August 31, 1945, Lieutenant Commander Nukio Nambu presented 2 samurai swords to Lieutenant Gen as symbols of surrender. The largest submarines ever built had fallen into American hands without firing a shot in anger. On September 2, as the formal surrender ceremony took place aboard the battleship Missouri in Tokyo Bay, Vice Admiral Charles Lockwood, commander of Submarine Force Pacific Fleet, ordered his personal flag hoisted aboard both the I-400 and I-401. It was a symbolic gesture. The American submarine force had captured the most advanced undersea vessels in the world. The Americans studied the submarines intensively. Engineers examined every system, photographed every component, documented every innovation. The aircraft hunger's construction methods were analyzed in detail. The catapult system was tested and measured. The snorkel, which allowed diesel engines to operate while the submarine remained just below the surface, was studied as a potential addition to American designs. The Inui coating was scraped and analyzed in laboratories. Double hull design attracted particular attention. No American or German submarine used this configuration. The figure 8 cross-section provided structural strength that conventional single-hull designs could not match. Some historians have speculated that Soviet submarine designers may have drawn inspiration from similar concepts when developing their Typhoon-class ballistic missile submarines in the 1980s, though direct influence remains unconfirmed. The concept of submarine launched aircraft, while impractical for conventional bombers, would evolve into submarine-launched missiles that became the backbone of nuclear deterrence during the Cold War. But the Americans also faced a problem that grew more urgent with each passing month. The Soviet Union demanded access to the captured submarines. Under the terms of the POM agreement that ended the war, Japan's military equipment was to be divided among the Allied powers. Soviet engineers wanted to examine the same technology that American engineers were studying. Soviet naval intelligence had heard rumors of the massive submarines and wanted to see them firsthand. American commanders recognized the threat immediately. The Soviet Union was no longer an ally, but an emerging adversary. The Cold War was beginning. Soviet submarine technology lagged behind American and German designs. Access to the I-400 class could accelerate Soviet development by years. The decision was made at the highest levels of the Navy Department. The submarines were too valuable to share. They would be studied thoroughly and then they would be destroyed. In late 1945, the I-400, I-401, and I-14 were prepared for the voyage to Pearl Harbor. American prize crews of 4 officers and 40 enlisted men were assigned to each vessel. The submarine's Japanese crews remained aboard to operate the complex machinery under American supervision. Japanese motor launches were loaded onto the decks to serve as lifeboats in case of emergency. The flotilla departed Sabo on December 11, 1945. Escorted by the submarine rescue vessel Greenlet. The voyage was difficult. The submarines were uncomfortable in rough seas. The offset conning tower at massive hangar made them roll heavily in swells. Many American sailors became seasick. One crew member later complained that the vessel bounced like a cork in rough weather. They stopped at Guam from December 18 to 21, then at Atoll anywhere in the Marshall Islands, and later at Kwajalein for refueling and supplies on December 26 and 27. The submarines continued their voyage. They arrived at Pearl Harbor on January 6, 1946, greeted by a Navy band and local officials eager to witness the legendary vessels. Over the following months, engineers conducted extensive evaluations. Every system was scrutinized in detail, and each innovation meticulously documented. Photographs and measurements filled volumes of technical reports. American designers incorporated many of the lessons learned into future submarine plans. Eventually, the submarines were destroyed. On May 31, 1946, the I-401 was towed to deep waters off Koloa near Oahu. The submarine Trumpetfish approached and fired 2 Mark 18 electric torpedoes, striking the vessel and sending it to the ocean floor at 2,300 feet. Carrying its secrets with it. On June 4, the I-400 followed. Trumpetfish fired 3 Mark 18 Mod 2 torpedoes. Vice Admiral Alan Mack, commander of the Submarine Force Pacific, and Commander Lawson Rajay, commander of Submarine Division 52, observed the sinking from aboard Trumpetfish. They watched the largest submarine of World War II slip beneath the waves. The I-402, which had been converted to a fuel tanker and never saw combat, was scuttled off the Goto Islands near Nagasaki in April 1946. The I-14 met the same fate off Oahu on May 28. The U.S. Navy officially reported having no precise information on the locations of the sinkings. The technology would remain hidden from the Soviet Union. For nearly 70 years, the I-400 rested undiscovered in the depths of the Pacific. The seafloor southwest of Oahu is a landscape of rocky outcrops, sediment plains, and scattered debris from decades of military operations. Sonar surveys revealed hundreds of anomalies, any of which could be a shipwreck or simply unusual geological features. Identifying them required patient investigation, careful analysis, and the resources to send submersibles to examine each promising target. The Hawaii Undersea Research Laboratory at the University of Hawaii had been searching for lost submarines since 1992. Using the deep-diving submersibles Pisces 4 and Pisces V,
researchers had located several Japanese submarines from the Pearl Harbor attack. The I-401 was found in 2005, but the I-400 remained elusive. Terry Kirby, operations director at the laboratory, had studied historical records for decades. He knew the approximate area where the submarine had been scuttled, but approximate was far from precise. The seafloor in that region covered hundreds of square miles. On August 1, 2013, Kirby piloted Pisces V on a maritime heritage dive funded by the National Oceanic and Atmospheric Administration. Dr. James Delgado of NOAA's Maritime Heritage Program and Dr. Hans van Tilburg, the Pacific Islands Maritime Heritage Coordinator, were aboard as observers. They were investigating multi-beam sonar anomalies identified during prior surveys. The submersible descended through the darkness. At 1,826 feet, the seafloor emerged under the lights. Kirby guided the vessel toward a target that appeared promising on the sonar charts. As they neared it, shapes began to materialize from the gloom. Kirby immediately recognized the significance. The aircraft launch ramp stretched along what remained of the forward deck, the deck crane protruded from the structure, and torpedo tubes were arranged in the distinctive pattern of Japanese submarine design. The vessel was enormous, far larger than any other submarine wreck in Hawaiian waters. The I-400 had been located. Kirby described the moment as thrilling when the outline of the giant submarine appeared from the darkness. The wreck lay partially collapsed from the torpedo impacts nearly 70 years earlier, yet the hull remained largely intact. The hangar structure that made the submarine unique was still identifiable. Delgado called the discovery technologically significant. The design features of the large watertight hangar represented an important step in submarine design evolution. Following World War II, submarine experimentation and design continued in this direction, eventually enabling ballistic missile launching capabilities. The discovery was announced in December 2013 after coordination with the U.S. State Department and officials from the Japanese government. The wreck site is protected under federal law as a significant maritime heritage resource. Van Tilburg described it as a reminder of pivotal events and sacrifices, emphasizing that understanding these unique weapons of the past and shared history reflects progress from animosity to reconciliation. In March 2016, Pisces V returned to the wreck site with a specific mission. The submarine's bell had been located in the debris field during earlier surveys. With a permit from the Naval History and Heritage Command, researchers carefully recovered the bell, lifting it from 547 meters and placing it in a recovery container. The bell, just over 13 inches in diameter at its base, bore a crack, likely caused by the torpedo explosions that sank the vessel. It now resides at the USS Bofin Submarine Museum at Pearl Harbor, serving as a tangible connection to the largest submarines of World War II. Visitors can view the artifact and learn the story of vessels designed to threaten American shores but never fired a shot in anger. A single Aichi Siren aircraft survives and is displayed at the Smithsonian National Air and Space Museum's Stephen F. Udvar-Hazy Center near Washington. The aircraft was surrendered at the war's end by Lieutenant Kazuo Akatsuka, who flew it from Fukuyama to Yokosuka. The Navy donated it to the Smithsonian in 1962. Restoration began in 1989 and was completed in 2000. The I-400 class submarines never attacked the Panama Canal. They never struck the American fleet at Ulithi. They never launched a single aircraft against an enemy target. The largest submarines of World War II surrendered without completing their missions, yet their legacy endures. The concept of projecting air power from beneath the sea evolved into submarine-launched ballistic missiles. The double-hull design influenced later submarine construction. The technology studied by American engineers in 1946 shaped decades of undersea warfare development. Admiral Yamamoto died before realizing his vision. Captain Arasumi died rather than face judgment for his crimes. Commander Kyuzet and Lieutenant Commander Nambu survived the war. Pilots of the 631st Naval Air Group returned to families who never learned how their sons and husbands had flown one-way missions against the American fleet. The I-400 rests on the ocean floor near Hawaii, 1,800 feet below the surface. The vessel, designed to strike America from the sea, now lies within sight of the coastline. It was meant to attack, yet stands as a monument to engineering ambition, a reminder of what desperate nations attempt when facing defeat, and a testament to the secrets the ocean keeps. If you found this story compelling, please consider liking this video. It helps share more forgotten stories from World War II. Subscribe to stay connected to untold histories. Each story matters. Each deserves to be remembered. We would love to hear from you. Leave a comment below with where you're watching from. Our community spans from Texas to Tasmania, from veterans to history enthusiasts. You are part of something special here. Thank you for watching and for keeping these stories alive.